6 steps in hypothesis testing. Population proportion, problem 1. 6 steps common to all tests of significance. Number 1, state the null. This is usually the assumed value for the population parameter. It should involve an equal sign. State the alternative. This is normally the claim. This is what the researcher believes. It should have a greater than sign, or a less than sign, or a not equal to sign. State the type of tail. So that'll be a left tail, a right tail, or a two-tail. Number 2, state the predetermined significance level, alpha. Alpha normally is 0.10, 0.05, or 0.01. Number 3, calculate the value of the test statistic. This will come from the data from the sample. If we are computing population mean, calculate the degrees of freedom. Number 4, find the probability value, called the p-value, that corresponds to the calculated test statistic. The p-value can be found by using software, the calculator, or by using a table. Number 5, determine what the p-value indicates. If the p-value is greater than alpha, then we cannot reject the null. The null is better supported by the data. The data results are not statistically significant. The data results are not beyond those expected by chance variation. If the p-value is less than or equal to alpha, then we reject the null and conclude the alternative. The alternative is better supported by the sample data. The data results are statistically significant. The data results are beyond those expected by chance variation. So the p-value determines the outcome of the significance test. Number 6, state the conclusion in clear English. The template for the 6 steps looks like this. Step 1, we have our null and the alternative and type of tail. Step 2 is our alpha level. Step 3 is the value of the test statistic. So this will involve a formula. For population proportion, we use a z, and this is the formula. So p sub 0 is the null, the assumed value of the population proportion. X is the number of items that have the certain characteristic. N is the number in the sample, and p hat is x divided by n, the sample proportion. Number 4, we calculate the p-value by using a table, StatCrunch, Minitab, or a graphing calculator. Step number 5, we determine if we fail to reject the null, and that happens when the p-value is greater than alpha. If the p-value is less than or equal to alpha, then we reject the null and we conclude the alternative. So we have a saying, when the p-value is low, h of o must go. That means we reject the null and we conclude the alternative. Step number 6, we state the conclusion in clear English. Let's do an example using this outline. In a study of 11,000 car crashes, it was found that 5,720 of them occurred within 5 miles of home, based upon data from Progressive Insurance. Use a 0.01 significance level to test the claim that more than 50% of car crashes occur within 5 miles of home. So when you're doing a problem like this, you want to label the information that we're given. First thing is the 11,000, that's how many were in the sample. We're interested in the number of car crashes that occurred within 5 miles of home, and that was 5,720. The alpha level is 0.01, and the claim more than 50% of car crashes is the alternative hypothesis. So step number 1, the claim is given in the problem. More than 50% of car crashes occur within 5 miles of home. Given this, we can write the alternative. P is more than 0.05. Now we can also write the assumed value of P. The null will always have an equal sign, so P equals 0.5. Step number 2, we have our alpha level, 0.01. Step number 3, we will use the information from the sample to compute the test statistic. So we have X is 5,720, N is 11,000, P hat, the sample proportion, is X divided by N. So if we take 5,720 and divide it by 11,000, we have 0.52. Step number 4, the p-value will come from this test statistic once we put the values in our z formula. Step number 5, we make one of two choices. We fail to reject the null, or we reject the null and we conclude the alternative. If we fail to reject the null, we state there is not sufficient evidence for the claim. If we reject the null and conclude the alternative, we state there is sufficient evidence for the claim. Step number 6, we want to state the alpha level first. Then we state if there is sufficient evidence or there is not sufficient evidence for the claim. And the claim needs to be in terms of the problem. So let's use technology to actually compute the test statistic and the p-value using StatCrunch. We go to Stat, Proportion Statistics, one sample with summary. We type in our X, type in N, we put the value of the null here, and then we choose greater than, less than, or not equal to. Then we hit compute. The output is given, and we can check to make sure our null and the alternative is correct. This is p hat. This is our test statistic, and normally we round this to 2 decimal places, and here we have our p-value. And StatCrunch is saying the p-value is less than 0.0001. In Minitab, we go to Stat, Basic Statistics, one proportion. We select Summarize Data. We type in X, then N. We check Perform Hypothesis Test. We put in the null. We click Options. Here's where we change the alternative. In this case, we want greater than. Then we need to check Use test and interval based upon normal distribution. That's using the z. We click OK. And in the session window, we see this is our X, this is our N, here's p hat, this is our test statistic, 4.20, and this is our p-value. Now this does not mean 0, this means rounded off to 3 decimal places, it's 0. So this is a small number. Using the TI graphing calculator, we go to Stat, then we move from Edit to Test. Number 5 is one proportion z-test. We type in the null, 0.5, X, N, we choose greater than, and we hit Calculate. The calculator gives us the z score, the test statistic, 4.20 rounded off, and then here's the p-value. Now the p-value is written in scientific notation, and basically 1.3637887 e to the negative 5 is scientific notation, means we need to move the decimal place 5 places over, and the p-value is approximately 0.0000136. It is a very small number. So even though StatCrunch, Minitab, and the graphing calculator all have different values of p, in the big picture, we're going to come to the same conclusion. So using our outline, we have P equals 0.5. That's the assumed value of P. The claim is P is larger than 0.5. This is a right-tailed test because this is a greater than. Step number 2, alpha is 0.01. Step number 3, using the data from the sample in our Z formula, plugging in the values, we have 4.20. That's our test statistic. Number 4, we have a right-tailed test. So this area is our p-value, and our p-value using what StatCrunch said is 0.0001. Step number 5, so we say because the p-value 0.0001 is less than alpha, which is 0.01, we reject the null and conclude the alternative. When the p-value is low, H of O must go. Step number 6, at the alpha equal 0.01 level of significance, there is sufficient evidence to support the claim that more than 50% of car crashes occur within 5 miles of home. Thanks for watching.